Welcome back. In this lecture, we will cover the topics on multiple inheritance and friend functions. What will we learn today? In this lecture, we would be extending inheritance to take care of multiple inheritance. We would be using multiple inheritance, recognizing particular problem posing by multiple inheritance, applying virtual inheritance, and we look into friend function, particularly in C++. Understanding, declaring, and using a friend functions to access the data from two classes. Multiple inheritance. We have learned a derived or child class inheriting from a single base of parent class. Now it is time we see how we can inherit from more than one base of parent class. We call this method multiple inheritance. Using single inheritance, we know that a base class may have many derived classes. For example, a suspicious company might create an employee base class and derive contract employees, hourly employees, and slaves. A greedy car salesman might sell different car models, roadsters, and junk cars. When a child classes derive from a single parent, we call it single inheritance. Using multiple inheritance, a child class derived from more than one parent class is called multiple inheritance. An example can be the multiple inheritance of an RV, which is both a dwelling and a vehicle. For example, suppose you work for a financial service company and have already developed two classes of objects on which you make loans. The classes are named vehicle and dwelling. The vehicle class data member contains the vehicle identification number, the make, and miles per gallon, simple constructors, and display. Another class is dwelling. It is something like a house, a flat, or a place of residence. It contains number of bedrooms, areas in square feet, simple constructors, and display. So let's introduce another child class which inherits from vehicles and also dwelling, and we call multiple inheritance. Next, suppose a client applies for a loan on a recreational vehicle called RV. The RV, that is a vehicle, you drive it, it runs on gas, but this RV is a dwelling where you cook, you sleep, you live in it, at least during the road trip. This new class named RV inherits from both the vehicles and dwelling, as shown in the class diagram. The RV class inherits from both vehicle and dwelling. So both classes are listed after the colon in the class header, separated by a comma. The class access specifier for each is public. You also could choose private or protected. The RV class includes all the data member of each of its parent classes. In this case, the child class contains no new data field, but it could. The RV class also has access to the parent's function and adds two of its own, a constructors and a display function. 5 arguments are required in the header for the RV class constructors. 3 are passed to the vehicle constructors, and the other 2 are passed to the dwelling constructors. Additional arguments could have been required and used within the RV constructors. However, in this example, because the RV class declares no new fields of its own, the constructor body is empty. We can place any statement we like within the RV class display function. In this case, because the parent class already contains usable display function, those functions are simply called from the child. The scope resolution operators are necessary with the two calls to the parent display function, both to distinguish them from the child class function with the same name, and also to distinguish them from each other. If the child class function has not named display, and only one parent class contains a display function, then no scope resolution would be necessary to use the function. Adding new constructors using parent class, that is, pre-constructed class used for the identification numbers made of vehicles, miles per gallon, number of bedrooms, and square feet do not have to be redefined in the RV class, because their definitions were already handled by the parent class. In the main function, when we call anRV.display function, for example, in this display function, writing the details of the display functions was streamlined because much of the output has already been formatted in the parent class version of the function. Of course, this example is short to help you follow the logics. But in a class with dozens or even hundreds of members, well, you can imagine that the time saved by inheriting from already developed classes will even be greater. Duplicated inheritance. The multiple inheritance does have its own issue, that is, duplicated inheritance. Let us assume we have a student and an employee, both inheriting from a base class person. Additionally, we want to have a working student who is a child of both the employees and student. Working student seems to descend from the person two times, once as a student and once again as an employee. We can tell this point from the path going from the working student up to the students and up to the person, and another path going from working student up to the employees and up to the person again. Working student end up being a descendant of person two times. This is a duplicated inheritance, also known as the dreaded diamond, or sometimes called a deadly diamond of death. In addition, with the dread diamond, When a working student invokes the parent's display function, which display function should be called? And the display from the student or from the employee. To avoid this duplicated inheritance, we can use the keyword virtual when defining each of the child classes, students, and the employee. In this code example, we have four classes here. The base class person, the student and employee which inherited from the person class, the last working student class which inherit from the students and the employee. At the main function on the right hand side, we create an object WS of class working student. And we proceed to call each display function starting from the person, students, employees, and working student object WS. In the base class, we add a static integer called count. This counter is used to increment whatever the person class is constructed. Let's count our person objects by setting this counter in the constructors. When we executed this code, the first set of output is shown. Two objects of the type person has been created. This demonstrated the issue of the dreaded diamond. To overcome the duplicated inheritance, we use the keyword virtual. We add the keyword virtual before the public inheritance for person in the student class, and also before the public inheritance for the person in employee class. With the added virtual keywords, we execute the same main functions again. Now the second debug output is shown as follows. We could identify that the person created is now 1 and not 2 anymore. Therefore, with the help of the virtual keyword, there is only one person. To summarize the points about working with multiple inheritance, the example before was using a default constructor for all the inheritance classes. But when our base class has non-default constructors, working student must handle the construction needs for each classes, like students, employees, and the person. Friend of a class. This is a controversial topic in C++. Controversy is about the encapsulation. Whether friend violating encapsulation or enhance it, I leave it to you to decide where you are on this issue. Friend of a class only appear in C++, not in Java, and also not in Python. This topic expands your masteries on object-oriented programming in C++ by familiarizing with friend functions and the overloaded operators function. What if we want to allow a function which is not a member of any class to have access to the private or protected data members of a class? We use a friend function or a friend class. A friend function is a non-member function that access the non-public members of a class. A friend class is a class in which every function can access non-public members of another class. We talked about encapsulations and data hiding where no outside function could ever modify or use the private member data in a class. This approach ensures that all data members are used correctly and appropriately. So let's proceed to see how friend functions are applied. So far, we have learned the definition of friend function. Let's probe deeper to see how is friend function different from member functions. Here we have a class customer. This customer contains two private variables, two public functions, one constructor, and one display customer. Notice we have a friend function called display as friend inserted right at the top of the code section of the class declaration. The display as friend function is neither public nor private. It is not affected by the access specifier, meaning to say it can be placed anywhere in the code declaration. But in the class diagram, we usually place the friend function together with the rest of the member function. Another point to take note, the friend function usually has one class object as the argument. That said, the friendship must be granted, not taken, by using the keyword friend. Friend function is not symmetric. That is, when A is a friend of B, then B cannot be a friend of A. Friend function is not transitive. That is, when A is a friend of B and B is a friend of C, then A is not a friend of C. Friendship is not inherited. And finally, friendship is very powerful. It bypasses the function called overhead associated with the getter and the setter and the other class functions. Therefore, display as friend function is not a member of the customer class. Simply said, it is a friend. We can prototype it in any portion of the class declaration you want. The prototype of display customer and the display as a friend exhibit the differences between the class functions and the friend function. For display customer, it is a member of the customer class. It can be declared either private, protected, or public. It requires a scope resolution in the function header. Implicitly, it receives this pointer, the THIS, this pointer, with the reference to the object using the function. Whereas for the display as a friend, it is not a member of the customer class. It is just a friend. It can be prototyped anywhere, as it is not restricted by access specifier. It does not require a scope resolution. And finally, it takes the class type object as argument to have access to all the class members. How to access a function as friend? In other words, how do we use a member function and a friend function in the main? At the main function, we create an object richman of a class customer. We could use the member function richman.displayCustomer to show the value of the class member variable. We could also call a friend function display as a friend by passing the object argument with any class membership. We would still be able to access and display the values of the class member variable. Some facts about friends to take note. A class can have any numbers of friend functions. A friend function can be declared in the public, protected, or private section, or above or as in the previous example. The use of friend function should be limited. If a class contains public functions, we often use those functions instead. We, of course, are not required to use the word friend within the friend function name, but it makes the purpose clearer. Sometimes friend functions are required. That is, when we overload input and output operators, we shall see that in the next lecture, or when we access data from two unrelated classes, we shall see them in the next slide. Accessing data from two classes with just one friend. How do we do that? Now this code shows the definition of transaction class. In a program, it updates the customer account. We typically match transactions to the appropriate customer and then update the customer's balance owned using the transaction amount. In other words, a payment amount from the transaction class is applied to the balance due from the customer class. Let's consider the following activity. How about making balance due and the amount public? Well, no good. It violates OOP principle. And how about making the function members of a customer? No good again. Then it has to access the balance due, not the amount. Make that function members of the transaction? No good again. It has access to the amount but not the balance due. So if we create public gets and sets function for both the customer and transaction classes, we can access and alter their private data fields in a controlled manner. Now this is the approach we almost always will take because it supports the object-oriented principle of data hiding and encapsulation. In this case, this is possible, but it may become overly complicated. If we alter both classes to make the payment application functions a friend of both classes, now the function can use data from each class. Now sounds good to go. Let's go over to the next slide to see how we can do so. At last, defining the friend function. Here we have again two classes, transaction class and customer class. This time, we add the same friend function declaration called applied transaction with two objects, customers and the transaction as arguments. The friend function displays the data from the customer object, applies pay amount of transaction object to the balance due of customer object and display the transaction. Function applied transaction is a friend of both classes and takes two parameters, the customers and the transaction. As friend to both classes, the function has access to all the data it needs. If applied transaction was only a customer member function, then it would not have direct access to the private transaction data, and vice versa. But there's still a problem, a compilation problem indeed. Why? Let's move to the next page to check the workaround. To use the applied transaction function as a friend to both the customer and the transaction class, we must declare the function as a friend within each class. Then we can place the customers and the transaction class and the applied transaction function in the same file with a main function that uses them. Or we can place each in its own file and use hash include statement in the file with the main function. Whichever approach we choose, however, when we try to compile a main function that uses both classes, error messages indicated that some data members are inaccessible. The declaration refers to the both customers and the transaction class as parameters. If we place the customer class definition first in the file, and then declare the applied transaction friend function within the customer class definition, the class transaction has not yet been defined. If we place the transaction definition first, and then declare the applied transaction friend function within the transaction definition, the class customer has not yet been defined. Either way, one of the class definitions makes reference to an undefined class. A class must be declared before it is first used within the code. This is to help to inform the compiler that, hey, I'm telling you that there is a class customer declared earlier. Please don't make noise. So the forward declaration of the transaction allows the customer class to refer to the transaction class without causing a compilation error. Alternatively, you could use a forward declaration to declare the customer class and then define the transaction class and the customer class. In a nutshell, a forward declaration is a statement that lets the compiler know that a class exists and that the details will come later. In this case, we have customer class defined first. We need a forward declaration of transaction class to place before the customer class declaration. When two classes refer to each other, we can choose to forward declare either one, and then define the other class first. If two or more classes share a friend function that makes a reference to all the classes, we forward declare all the classes except one. We define the class we did not forward declare and include the friend function prototype in the class definition. We define all classes that we did forward declare together with the friend function prototypes. And then we define the friend functions itself. The literal steps shown 1 to 4 are based on good coding practice. Now finally, we can run the complete example. The debug output would show the display of the customer balance and followed by the transaction amount and the customer balance after the transaction. I think you get the idea now. Friends, in a nutshell. When a non-member function needs to access the non-public data from two classes, our choices are, first, using get and set functions that are public members of those classes. Or second, have the two classes declare friendship to one friend function so that it can use the data from each class. A friend function of a class is defined outside the class scope, but it has the right to access all the private and protected members of that class. The class can also be friends, in which case all the class members are friends. Such classes are often used for testing. We've come to the end of this lecture. What have we learned today? Multiple inheritance. A base class may have several derived classes. A child class can derive from several base classes. This is called multiple inheritance. When a class descends from two classes that both descend from the same base class, it is sometimes called the dreaded diamond. You need to prevent duplicated inheritance of the base class by using the virtual keyword. For friend functions are special functions that can access non-public members of a class, even though they are not the member of the class. Friend functions do not use the class name or the scope resolution operators in the function header. If we make a function a friend of multiple classes, it can use data from each class. I hope you have earned enough knowledge on multiple inheritance and friend functions. See you again in the next lecture.